Yeah, so let's get into the questions here, and we do have a lot of questions. One of them was, did you insulate the first floor panels?
Yes, we did. So the foundation that the building sits on in its final landing place is not conditioned space. We insulated the floor panels to, it was something like R60 or R65, so that the shell of the building, the insulated shell of the building ends with that floor assembly.
Great. And how are the floor boxes connected to one another?
So the at the edges where the panels meet, the two trusses on the end are a little bit shallower than the others, and we basically used a strip of the same 3/4 inch plywood that was going to be sort of the decking for the rest of the panel. There's a 6-inch strip that is screwed onto both sides of the connecting trusses, so that ends up being what connects them. And then we put the finished floor down, and then similarly the finished floor also has a strip that runs in that direction. So to take them apart, you take off that flooring strip, you take out the plywood strip underneath it, and then the panels are separated.
Thank you. Were the field installed sheathing laps at panel joists installed with nails or screws?
Could you repeat that?
Were the field installed panel joists installed with nails or screws?
The connections were all made with GRK structural screws.
Okay.
So those plywood joints, like I was talking about at the floor, and like the similar plywood joints on the wall and roof panels, all had GRKs at certain spacings to so that we would be able to kind of mount and dismount them.
Great. How thick is the final exterior wall assembly, including finishes?
It depends on which assembly. So we had the cellulose insulated panels were 12 inches total from outside to inside, and the straw bale ones were 17. And then that 5-inch difference, we put the straw bale ones on the east and west side of the first floor, and so that meant that the 2x4 frame, the interior side of the 2x4 frame, basically made a ledge, and that's what our second floor panels rested on. So that made it very easy to build the first floor walls, drop that second floor in without it having to fit extremely tightly, but it had a 5-inch ledge all the way around the interior for it to sit on.
Great. Can you talk a little bit about the decision to not have overhangs or a render on the exterior face?
Sure. The design with the no overhangs was kind of handed to us by the team at Ryerson. That was the look that they were sort of aiming to achieve, and so even though it's not sort of typically our practice to build without overhangs, it was something that they wanted to see as part of the design of the building, and keeping in mind that because it's the design comes from a row house design, there wouldn't be overhangs on the sides because you'd actually be butting up against another unit. And so we, because of the way we built it with a large sort of ventilated rain screen between the wall assembly and the metal siding, we felt pretty confident that between the metal siding and that rain screen, that should there be any leaks up at that top edge, they're not going to end up in the wall. They're going to go down this well ventilated rain screen cavity. And so the reason for not using renders is it's very hard to make a rendered finish that you can put up and take down multiple times. Renders are pretty thin and brittle and don't like traveling or bending or any kind of movement. So the metal siding was a much more feasible way to be able to put something up quickly and also be able to take it down again.
Great. Can you confirm that when you were saying negative emissions, you were talking simply just by using wood?
No, actually, not just by using wood, by using straw and cellulose and cork and mycofoam and any number of plant-based materials. So it was actually the insulation materials that make up the bulk of that total. And sometimes, definitely with the framing lumber, we don't count that wood as storage because we know so little about how those trees were harvested and what the sort of carbon impacts of the forestry that was going on to get that wood. It's so unknowable that we actually don't count that in our storage tally. We just count the emissions associated with harvesting. We did count the storage in the plywood panels because they were FSC certified, which at this time is a fairly good proxy that forestry practices were such that there wasn't a negative carbon impact at the harvesting side. Although I think there's still lots of work to do to be able to verify that. But so we rely, when we're doing our storage numbers, we rely actually mainly on waste stream forestry and agricultural and recycling streams to give us that storage.
Great, thank you for confirming that. How did you insulate the rim joist perimeters?
Well, it's a very sort of different construction than a typical building. The floor panels, essentially, there isn't really a rim joist. There was a thin LVL right out at the outside, but because the floor joists sit on top of the foundation wall and are the thermal envelope of the building, the insulation in that floor system lines up with the insulation in the walls above. And so by insulating those floor boxes, we actually don't, and because they're built as boxes, they don't really have a rim joist in the typical sense.
Mm-hmm. So a question here from the audience. Where did you draw the line for construction waste? I saw insulation came in plastic packages and the solar panels were peel and stick that had a protective layer for them. Just those two items alone, according to this commenter, would be more than 20 pounds of waste, I would think, and there's lots of other materials that are packaged just like this.
Yeah, so what we did with packaging, so that 20 pounds were things that had to go to landfill because there was no other option. So for instance, the cellulose bags, that plastic is something that is recycled in this part of the world, and so we were able to divert that to recycling. Yet the peel and stick from the back of the panels was some of what was in those bags, but because it's it was 23 sheets of paper, it doesn't actually add up to much. So what was in those bags were the things that there was no possible diversion for. So things like our wood scraps and our wood fiberboard scraps went to a local facility that makes fuel pellets out of that wood. The rewall material from the inside, that can go back into the drinking box recycling stream. So we were choosing materials that the materials themselves aren't anything that needs to go to landfill, and to the best degree possible, with the exception of that 20 pounds of packaging that wasn't recyclable, everything else was able to be diverted.
What are your thoughts on heating and cooling being replaced with hydronics to fit disassembly and reconstruction and in this case, I think they're bringing up the concerns about refrigerants, which we know is a huge global warming potential. So just using hydronics to avoid refrigerants and being able to do it in a way that can be disassembled and rebuilt.
Yeah, I mean, the hydronics aren't a heating system, they're a heat delivery system. So, our intent was to use no fossil fuels. So, we could have done a heat pump to water, but I think, as soon as you get into hydronics, the type of, mounting and dismounting that we were trying to do gets really difficult. You've got water lines that have to be, taken apart and put back together again. Um, if this building was just intended to go up once, we might have considered a hydronic system, an electrically heated hydronic system. But the air source heat pump with the mini split head is simply the easiest, fastest, and cheapest way, and an extremely energy efficient way to do that heating. And with the refrigerants, it's totally true. If that's not installed properly and it leaks, we may have undone a bunch of our carbon storage. We're this year starting to work with Sandon, which makes a CO2 air to water heat pump. So we're anxious to move away from those refrigerants, but in the balance for this project, the amount of refrigerant is quite small. We had a really good installer, and we're sort of hoping that that it doesn't leak, and that the owner will sort of, if it ever does need repair or replacing, will take care in doing that. But it's definitely, there's a lot of push towards heat pumps because of their efficiency, but there actually isn't a lot of talk about the potential danger of the refrigerants as greenhouse gases, and that's for real, and a serious issue, and something that we're trying to address by moving to heat pumps that don't have those types of refrigerants.
Hey, thank you. So there is a ton of comments and questions here about the $250 a square foot cost, and a lot of questions about how did the fact that potential product donations or student labor, I think those were the two big concerns. How were those factored into that cost?
Right. Well, we did get donations, but when we tallied up our budget, we just used the full commercial value of those donations. So while we didn't necessarily pay 250 a square foot, that's what it would have cost if you had to buy the materials that we got donated. And then the labor side is definitely a guess. We do have the student labor, but we also have 3 full-time faculty working on the building, and quite often, as a school that has been working with students in this way for 15 years, we have a pretty clear understanding that we're actually in a lot of ways not getting free labor that way. That if we just had our 3 well-trained faculty people putting up the building, they would do it at pretty close to the same speed as we do when we're trying to teach students how to use tools, how to do these things, how to measure, mark, and layout, and stuff like that. So it may not be a 100% accurate budget, which is why we gave a range, and why I quoted the top of the range. But we're quite confident that we understand what it would take an actual crew to put this building together, and based our sort of labor part of that budget on that understanding.
And then following up on that, do you know how much time was potentially saved doing it modular as opposed to just building it on site?
Right. Well, I don't, the thing with modular is I don't know that you necessarily save time overall. It takes, as long to build the components in the shop as it does to build them on site. But your actual site time, our installation from, showing up on site to walking away from a finished building is about a week. So, that doesn't reflect that there was all the construction time in the shop beforehand, but it definitely minimizes that site time, which can be expensive. It also means that while we're working in the shop. We have no rain days. We have no, sort of cancellations. We don't have any, our supply issues are a lot more straightforward because we can bank those materials in the shop. And so, overall, there's probably not a huge actual labor savings, which is why it ends up costing about the same. But what's really reduced is that site time. And especially when we're looking at kind of urban infill housing, which is what the Ryerson team was initially looking at, there's a huge amount of savings to a developer in not having that site be a construction site for 4 to 6 months, but instead maybe only for a few weeks. And so, at scale, I think that's where you'd see the cost savings. But on the labor side, it takes as much time to build a wall in a factory as it does to build a wall on site. Although it is kind of nice that everything's lying down flat for you, so there might be a little bit of savings that way. But it's not huge. The real savings is on eliminating the site time.
Can you talk about the plumbing design and if there was anything unique about that in regards to it being ready for disassembly?
The main thing that was unique is, we just made sure in the design there's actually only one wet wall in the building, so that the kitchen and the bathroom back onto each other. And so we only needed plumbing in that one wall, which meant that we were actually able to place all the pipes and have them move with the wall, and then just in its final version, actually hook up the P-traps and everything and the fixtures to it. But we didn't have to deal with any horizontal runs anywhere in the building. It was just that one wall had everything in it. And again, that might not be a consideration if you weren't trying to move the building multiple times and reuse it in that same format. But that was definitely something for us for this building that we needed it to be able to come apart and go together multiple times.
Do you have any, I guess, operational usage, utility usage follow-up information on this project? Is it, and also, if you did energy modeling, is it coming close within your targets or off, or anything to comment there?
Actually, it's funny that doing the webinar today sort of cued me to get in touch with the owner who moved in late 2018 to sort of say, hey, can you send us some bills and some data? So I actually don't have that, but hopefully we'll get that soon. At this point, she should have at least a year and a half of maybe even 2 full years of information. So I'm sort of looking forward to getting that, but I don't have it now.
Have you done any actual indoor air quality testing just to verify the low emissions of the product?
We did when we were sort of first finished the construction up there. We obviously haven't done any sort of long-term monitoring once the owner moved in, but yeah, it's incredibly clean. Like there was literally nothing in the building that had anything off-gassing, and we totally used the precautionary principle of we only use things that were sort of proven to be safe, not things that just have not yet been proven to be potentially toxic. So once it starts that clean, the initial air quality is really good. Then obviously it depends a lot on the occupants of the building from then on. It only takes somebody smoking in the building or using off-gassing cleaners or body care products or something like that to really change that. So obviously there's a good ventilation system, but there's also no control over that. But the materials themselves are very clean.
Is there any, people are wondering if there's any plans or specific construction details that you are willing to share or are sharing on your website in regards to this project?
Yep, there's some pretty good documentation on our website. I actually trimmed some of the drawings out of this slideshow to fit within the hour, but The floor plans are there, the sort of layout for panelization is there. And actually, I would say, the biggest of our lessons learned on this building in terms of the prefabrication side is the roof and the floor panels were incredibly quick and easy to put together because they were basically big long rectangles, and in some ways we kind of blew it on the walls. If people noticed, it wasn't a great building for prefabrication because it had pitched walls and different roof pitches on the two sides, so different heights. But I think the big mistake we made was in panelizing the walls. Quite a few of them were panelized, the north and south side, to be the full 2-story height, so that they were kind of divided vertically. And it would have made a lot more sense to just have made one long panel for each of the sides of the building that's 1 story high, and then another panel for the 2nd story. We would have cut the number of panels in more than half, and had a lot less seams to deal with. So if we had thought about treating the walls more like floors, in the past I've always done just wall panels, and it's definitely been partly an issue of size and weight and how we move them, that we divided them up into smaller squares. But we realized, oh yeah, we could have done the walls just like the floor, the roof, in big long sections, and really speeded up the construction and minimize the number of connection points and air sealing points. So that was definitely our big takeaway, was make big long straight wall panels just like we did floor and roof panels.
Great. A lot of people are asking what was the square footage number of bedrooms and bathrooms?
It's a 1-bathroom. It's just under 1,100 square feet, and potentially 3 bedrooms. The way the owner actually had us configure it, there's 1 downstairs bedroom, and the entire loft area is 1 big open area. But you could easily divide that into 2 or possibly even 3 separate rooms. But it's currently one large area.
One question I had was, I saw did you use straw bale for a portion of the insulation and cellulose for another portion? I guess I didn't quite understand the mixture there.
Yeah, so we did the east and west first floor walls were panels with straw bales as the insulation, and all the rest of the walls had dense packed cellulose.
Okay, and in some of the straw bale you did basically the mushroom foam, correct?
That's right. On one of them we did, right, just to try it out and see how it worked.
Do you have any thermal imaging, I guess, during the winter of all these different wall types to see which ones are performing better or not?
No, I don't actually. It's something we just ordered a camera, so it's something I'd like to go do.
Yeah.
I'm not sure how much we'll see because we built it with a service cavity on the interior. So that interior plywood is sitting 1.5 inches off of the wall panels, and so I don't know. It'll be interesting to see, how much we see through that. I know when you do thermal imaging of single stud walls, you can actually see the studs and really check out where there are bridges and where there are differences. But I'm not sure how visible that will be with that air gap between the interior siding and the wall itself.
How does building code, how do you work with the code officials to handle a project like this?
Yeah, I mean, that one is definitely interesting when you're doing prefab, because obviously you're sealing up components without an inspector on site to check out the framing and things like that. So we had to have a structural engineer on the project, and essentially that person's visit to the the factory site as we were building was basically, they were signing off for the building department saying, yep, I've been inspecting the construction as it's been going and everything is as I expect to see it. And then when we put it up in its final location, we had the inspector come before we put the interior or the exterior cladding on the walls. So that person was able to not necessarily inspect the insulation, but to see the air barriers, the air sealing. Obviously the wiring was inspected and the plumbing was inspected before we closed in those walls. So that's, I guess, having the engineer stamp off on the structural components was really the only difference.
Was that engineer sent actually from that local place where it was finally set down, code department?
No, that was our sort of project structural engineer who was essentially just taking responsibility for that inspection, and the building department was, we checked with them in advance, would this be sufficient for you to have somebody with a seal come and inspect and sign off, and they were okay with that.
In assembling and disassembling the building, would anybody experience any kind of quality degrade in the materials being used that you can think of?
I mean, slightly, depending. There were especially on the exterior air barrier. There were a couple, a couple of times that would get torn, from one panel rubbing against another in transport, or as it was being installed. But in general, no. And even the third time it went together, we didn't have anything more than a sort of quarter-inch difference in tolerance over the full height of the building. So it actually worked out quite well. By the third time, we were using new screw holes for the fastening. So the first two times we ran the screws into the same holes, and on the third time, not that any of them didn't feel like they were holding, but we just decided to either change those locations or add a couple more just to make sure.
And it looked like you had mentioned you did an exterior and an interior air barrier. Why both?
That's just sort of general practice for us. We're trying to hit really good levels of air tightness, and so it's that redundancy is helpful. But also because we're treating that exterior like a rain screen, and we didn't have any overhangs. We wanted to make sure that there was a really good barrier protecting the materials on the outside, and then because the majority of the vapor drive in our climate is from the inside, we wanted to go with one on the inside to slow that down. So it just seemed to sort of make sense to do that. And it's really nice, when you're shipping those components, if they've got the wrap on both sides, they're pretty much weather ready for whatever might happen while they're on the road or while they're being installed. So it just seemed like a good way to do it.
Does a crawl space have a heated zone for plumbing to come in and out of ground?
It does, yeah. Yeah, it has a small framed in room. So the wall itself, that Nexem insulated concrete form is an R28 wall. So that space, the whole space is insulated, and so is the slab floor under it. And then we have just sort of like a framed in section for the plumbing that is connected to above. So there's some heat leaking from above into that one area.
Do you know what the watts per square foot was on the solar film?
No, I know that each module is 120 watts, and they are 14 inches wide by about 8 feet long.
Hmm.
And the company is called BIPV Co. They're from the UK, so you could look up the specs there, but I don't remember exactly. It's
Oh,
definitely lower than the mono or the polycrystalline modules.
hmm.
The output isn't as high per square foot, but for us the trade-off in even if we weren't moving it again, I would be interested in using these because it's really nice to do a solar installation that doesn't poke a bunch of holes in the roof. And from the embodied carbon point of view, getting rid of all that glass and aluminum is also really helpful. So it had some advantages for us, especially in the dismounting and remounting that made it worthwhile for having the less output per foot.
So someone is looking like they're mentioning that there are now certifications. I don't know if they're for factories or what, for prefab standards. I don't know if that's something you know about, or I guess they're wondering if you're planning to use that in any future projects.
No, probably not. I know here in Canada there is a CSA standard for it's typically for sort of like mobile homes, but the same standard right now would get applied to somebody making prefab building elements or prefab building sections. But for us, we're just a small school. We only do 1 or 2 buildings a year, and not always prefab. So the cost of we don't even have a facility. We built that in a sort of flying shop under a tent. So it's not really practical for us, but definitely the other companies that are doing prefab more seriously. Like there are a couple here in Ontario now that make components a lot like those ones that we made. There's Benson Wood in the northeastern U.S. So there are places doing that, and I know that they are sort of using that way to be able to certify. But for us, it's just we're not really in the business. We're in the business of teaching people, and so we wouldn't want to sort of maintain a license or a shop to do that.
Got it. Well, I think we're pretty much at our time here for how much time we have left. There are still a lot of questions, a lot of specific questions. So with that, Chris, where can people reach out to you to ask any other questions they have, learn more if they can work with you, learn more about this project?
Definitely our website, endeavorcenter.org, has more details about this project and all the projects we've done, and there's a contact link there and stuff. So yeah, if people want to learn more or find out more or get a hold of me, endeavorcenter.org, spelled the Canadian way, is the best way to do that.
All right, Chris Magwood, Endeavour Centre, thank you so much for doing this. And everybody, please stay safe, stay in, stay away, and hope the best. You have a good rest of your week. Thank you. Bye.
Be sure to check out all of our courses available online that you can watch anytime and anywhere to pick up your CEUs. Before you go, make sure to subscribe to us on YouTube to get weekly updates and stay up to date on green building science courses, webinars, and home tours. Thanks again. Thanks for watching. Please continue to watch the next part of the session to complete the course and get your continuing education credits. Be sure to check out all of our courses available online that you can watch anytime and anywhere to pick up your CEUs. Before you go, make sure to subscribe to us on YouTube to get weekly updates and stay up to date on green building science courses, webinars, and home tours. Thanks again.